Hi everyone, myself Navyatha working as Assistant Professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. Today I am going to discuss about the topic concept of functional dependency. The overview of my presentation includes definition of functional dependency and types of functional dependencies. So what is a functional dependency? Shortly here we call as functional dependency as FD. So in this whole slides I used to use instead of functional dependency, shortcut form FD, right? So what is functional dependency? If column A of a table uniquely identifies column B of the same table, then it can be represented as A tends to B. The functional dependency is represented by the symbol arrow mark. So here A is one column, B is another column which belongs to the same table. If A derives B uniquely, then we call it as A is functional dependent on A tends to B. Here attribute B is functionally dependent on attribute A. So let us discuss this one with a simple example. What is that one? Let us consider one table which consists of SID and SName, student ID and student name. So let us have SIDs as 1, 2 and student name as XYZ, and this student name is also XYZ. So what is functional dependency here? If one column of a table can be able to uniquely derive another column of a table, that means with the help of IDs I can derive the names, the persons uniquely. With the help of IDs only, I can able to uniquely identify these persons. So without SID, can I able to identify these two persons simply by name? Why? Because the names are same. Here we have redundant names. Only with the help of IDs only, we can able to identify the names. So the same concept. Here, what is that one? This is A, SID is A, S name is B. Okay. If A derives B uniquely, then we can say that B is functionally dependent on A. B is functionally dependent on A. So it is represented by the symbol arrow mark, and an attribute on left hand side is called determinant and the attribute on right hand side is dependent. So here what we call as A tends to B. What this one is called as, this is nothing but SID as I said in an example, and this is B is nothing but S name. The names can be same but IDs may not, right? So whatever the IDs we have, for example roll numbers, PAN, Aadhaar, for different persons we have unique IDs, not same IDs will be generated, right? But the names can be same. So if at all I used to identify or I used to uniquely identify B with the help of A, then we can say that B is functionally dependent on A and A is determinant, B is what we called as dependent. That is what meant for FD, functional dependency. So let us discuss this one with some examples. Let us take different cases here. So here SID is 1 and the name of this SID is Ram, and SID is 2 and the name of this SID is Tom. So here I can say that SID derives S name uniquely. Why? Because for two different IDs we have two different names. So here this we can write in the form of FD. This is one FD. What is that one? SID derives S name uniquely. Here left one is called as what? Determinant. Right one is called as dependent. Right call. Next, let us see the case 2. SID is 1, name is Ram. SID is 1, name is Ram. That means this is also a valid FD. How? Here the ID and the person are the same, right? ID and the person are the same. That means we are storing the data repeatedly. We are storing the same person data repeatedly. That is also a valid FD, right? Now let us see the third case. What is the third case? The ID is 1 and his name is Ram. Again the ID is 1 and then his name is Tom. Is it possible in real scenarios? No, right? The same ID or same Aadhaar can be given to two different persons? No. So this is invalid FD. Why? Because for an attribute, if at all we have to represent this as an FD, then one of the columns must derive other columns uniquely. Then only we can able to derive an FD. But here the same SIDs has been given to two different persons. So it is not an FD. So case 3 is invalid. Case 3 is invalid. Let us discuss with case 4. SID is 1 with the name of Ram and SID is 2 with the name of Ram. So here also I can say that SID derives S name uniquely. So we can have a person whose name is same. 2 or 3 persons whose name will be same but different IDs. To identify them uniquely, only with their IDs, PAN, Aadhaar or roll numbers, we can able to identify. That is what the case here. So with the different IDs and same names. This is also a valid FD. Let us see some more examples. Here I used to consider two columns, A and B. So here I have represented some of the cases. Let us discuss whether these are valid FDs or not. Clear? So here A1 derives B1 and A1 derives B2. Let us suppose think this one as SID and think this one as S name. This is one column and this is one column. Whether two SIDs will be given to two different persons? Same SIDs must be given to two different persons. So here what the thing is, A1s are nothing but the SIDs. Right? These are just like Aadhaar and PAN. The same Aadhaar number must not be given to two different persons. That is the reason the case 1 is invalid. Right. Let us go for case 2. Here SID A2 B2 is derived by A2. B3 is derived by A3. This is a valid FD. Why? Because here two different SIDs are deriving two different persons. This is a valid SID. Next, let us deal with case 3. What is case 3? A1 derives C1, A2 derives C2, A3 derives C2. This is also a valid FD. Why? Because, so here this is unique one. A2 derives C2, A3 derives C2. Persons can have same names with different IDs. We can uniquely define the persons uniquely with their IDs. That is what the case here. Case 3 is also a valid FD. Next, what is case 4? See, same IDs has been given to two different persons. Whether it is valid? No, this is not a valid FD. Just like the case 1. Next, case 5. A2 derives D2 and A2 derives D3. See this case? A2, the same ID. Same ID can derive two different persons. Same ID can derive two different persons. No, right? That is also not a valid FD. And the last one is what? A3 derives D4. This is also a valid FD. So till now I understood, or I can understand that you people got an idea about FD, right? What is a functional dependency? Next, let us discuss about types of functional dependencies. What are those types? Here we have majorly 4 types of functional dependencies. Trivial functional dependency, non-trivial functional dependency, multivalued dependency and transitive dependency. These are the basic 4 types of functional dependencies: trivial, non-trivial, multivalued and transitive dependency. The reason why we are studying these functional dependencies, because here we used to handle redundancies. That means we used to remove redundancies. For that purpose, we have discussed decomposition concept in previous sessions. decompositions that means splitting the given table into 2 or more subtables. That is what decomposition is meant for. That is the best solution to remove redundancies that we have already dealt. So here, even though we are facing problems, then what is the what kind of solution that we need to do? So one of the solutions is nothing but what? Normalization. For that normalization concept, for that normalization to deal with this concept, we must have basic idea about FDs. We must have basic idea about functional dependencies. What are the functional dependencies? How we can able to represent functional dependencies? It purely depends upon the columns, right? That is why we used to, the reason that we are studying about functional dependencies is about to know about normalization. This is what the prerequisite to deal with normalization concepts. So here we have different types of functional dependencies. Let us deal with the first one, trivial functional dependency. So what is trivial functional dependency? Here A derives B is a trivial functional dependency if B is subset of A. If B is subset of A. So for example, see this one. What is the meaning of this one? Here there is no rule that only one attribute must derive another attribute. There is no such rule. A combination of some attributes can derive another attribute uniquely. Why? Because we can have more than one column as a primary key. More than one column as a primary key, right? That means two columns can be combinedly considered as a primary key. Why? Because if at all we want the data uniquely, then we have to combine in some cases we have to combine two columns as a primary key. In such cases, so how functional dependencies can be represented? So let us suppose here SID comma SName, only these two combinedly can derive SName uniquely. So here if at all we need to represent this one as a trivial functional dependency or not, what we need to tell as per the definition, the right hand side must be the subset of left hand side. So here if at all this is A, this is B. This is A, this is B. A derives B. This is what my functional dependency. Whether I used to tell this one as a trivial functional dependency, what I have to check? B is a subset of A or not. That one I need to check. If at all it is a subset, then we can say that it is a trivial functional dependency. So here SName is a subset of left hand side part. Yes, it is a subset. So we can say that this functional dependency is a trivial functional dependency. And one more point here you need to remember is all trivial functional dependencies are always valid. So basically here we have the reflexive rule. What is the reflexive rule here? If at all a column derives itself, SID derives SID uniquely and SName derives SName uniquely. This is what the reflexive property. If at all a column derives itself, then it is nothing but a reflexive property. So here it's basically related to reflexive rule. A derives A and B derives B uniquely. That is what trivial FD, trivial functional dependency. Let us discuss about non-trivial FD. What is non-trivial FD? Just opposite to trivial. That means the right hand side must not be a subset of left hand part. For example, let us consider this FD. FD means here what? Functional dependency. So extends to Y holds true where Y is not subset of X. In previous case, Y must be a subset of X, but here Y must not be a subset of X. That is what? Non-trivial functional dependency. What is the example for that? If SID derives SName, so here SName is not a subset of SID, the left hand side part. It is a non-trivial functional dependency. Similarly, SID derives SAddress. SAddress is not a subset of the left hand side part. So it is non-trivial functional dependency. Next, let us discuss about multivalued dependency. So, what is multivalued dependency? It occurs when there are more than one independent multivalued attributes in a table. Let us discuss this definition with an below example. So, here the bike model, manufactured year of this particular bike, of this respective bike, and the color of the bike. So, the bike model number is, for example, M1001, and which has been manufactured in the year 2007 with the color black. The same bike model in the same year, again they have released with color red. That means same model can have two independent values. See, when there are more than one independent multi-valued attributes for a particular attribute, then it is called as multi-valued dependency. So, here the same model can have two different values. This comes under multi-valued dependency. Next, what is transitive dependency? The last one, what is transitive dependency? Functional dependency is said to be transitive if it is indirectly formed by two functional dependencies. Indirectly formed by two functional dependencies. That is nothing but, let us discuss this one with an example. I used to deal a lecture to the students. If at all myself is A and I used to deal with the students and I used to give my lecture to the students, those students will be B. Let us assume that students will be B, myself, lecturers will be A. Right, lecturers give lecture to the students and the students among themselves give or else help those who didn't attend the classes on that specific days when the lecture derives or delivers a lecture. Here B and C are both are students only, right? So, here B are the students, those who attend the classes at that time, and these students can deliver lecture to the students, those who didn't attend the classes at that time. That means indirectly the lectures help these students only, right? Why? Because if at all I didn't deliver lecture to these students, how he can able to deliver lecture or help his friends? He can't, right? So, and one more thing here you need to remember that one. What is that one? A derives B, but B does not derives A. The vice versa may not exist, right? So, let us discuss this one with an example. See here, X tends to Z is transitive dependency if the following three FDs holds true. For example, what is the three FDs here? X tends to Y. First, X must derive Y, but Y must not derive X. The vice versa must not exist. And Y can derive Z. So, for example, here let us see XYZ. This is SID. Let us suppose this is SID, this is S name, and this is student address. So, SID is nothing but 1, 2. S name is XYZ and here also XYZ. And what is S address? For example, Hyderabad, and this is nothing but AP. Okay. So, we can say from this, we can say SID can uniquely derive S name, right? SID. Why? Because with the IDs only, I can able to uniquely identify these two persons with the help of IDs only. Without IDs, without considering IDs, how I can represent these two persons? I can't, right? So, with the help of IDs only, I can able to identify. But here, the concept is whether S name derives SID again? No, right? That is what the second point is meant for. If X tends to Y and Y must not derive X, that is what second point. And if at all these two, X tends to Y and Y must not derive X, and this Y can derive address. Another column. So, this is what the concept in transitive dependency. That is nothing but indirect way of representing the relations or attributes. That is what the thing. So, till now what we have discussed? We have discussed about what is a functional dependency. So what is a functional dependency? One column of one table or one attribute of a table can derive another attribute uniquely. Then it is called as a functional dependency. And we have seen what different types of functional dependencies: trivial functional dependency, non-trivial functional dependency, multi-valued functional dependency, and the last one is transitive dependency.